Hello, how's it going everyone? Welcome back to the channel. In this video, I'm going to show you how to build an AI-powered financial data analyst using Flowise and n8n. By the end, you'll have an AI agent that can analyze market trends, stock performance, and more automatically. If you're ready to transform the way you handle data analysis, stick around for the full breakdown and some expert tips along the way. Alright, let's dive right to the proper build step by step. Today, we're combining two absolute powerhouses in the AI and automation world, Flowise and n8n. Flowise is your all-in-one tool for building interactive AI agents with ease, and n8n is like the secret sauce that automates everything in the background. These tools together, absolute game changers. Imagine having an AI that can pull financial data from Google Finance, analyze stock trends, and give you insights without lifting a finger. That's exactly what I'm going to help you build today. Let's get started. First things first, let me show you how this full system works. Here we have the full logic on how we built this AI analytics agent. We are combining the capabilities of Flowise AI Agent Builder and the powerful automating efficiency of n8n. For our AI agent, Flowise will be our building platform of choice. Flowise AI is an open-source, low-code platform that enables developers to create custom applications using large language models, LLMs, with ease. Its intuitive drag-and-drop interface allows users to design complex AI workflows without extensive coding knowledge. Flowise supports various AI tasks, including natural language processing, sentiment analysis, image recognition, fraud detection, and recommendation systems. By simplifying the development process, Flowise makes advanced AI technologies more accessible to a broader audience. n8n.io is a workflow automation platform that enables users to connect and automate tasks across various applications and services. It offers a user-friendly node-based interface, allowing both technical and non-technical users to design complex workflows without extensive coding. With over 400 integrations, n8n.io facilitates seamless data transfer and process automation between tools like Google Sheets, Slack, and GitHub. Users can self-host n8n.io for enhanced privacy and control, or opt for the cloud-hosted version for convenience. Additionally, n8n.io supports advanced AI functionalities, enabling the creation of custom AI applications such as chatbots and data analysis tools. This Data Analyst AI agent will be powered by one of the most powerful LLM recently released. You probably heard about the recent release by the Anthropic AI team, the newest Claude Sonnet model. In terms of coding proficiency, Claude 3.5. Sonnet has made remarkable strides. It excels in understanding complex programming tasks, generating efficient code, and debugging errors. This advancement positions it as a valuable tool for developers, streamlining the coding process and enhancing productivity. The reason why in this AI agent we are going to build, we will leverage the coding prowess of the latest Claude Sonnet 3.5 AI model to power the data analytics and data visualization capability of our data analytics agent. Alright, enough of the intro already. Let's start with setting up our AI agent within Flowise. You can sign up for a cloud account from the Flowise website linked in the description below. However, when you sign up for the cloud account, you will be put on a waiting list before you can access and start building. So in my case, I will be using my self-hosted version of my Flowise instance. I did this using the cloud hosting provider called Render. Unfortunately, I will not be going through the setup in this video as this would be an entire tutorial. I will link an awesome full step-by-step tutorial by another YouTuber whom inspired most of this AI data analytics AI agent build we are going through today. His name is Mr. Leon Van Zyl. To start building, let's go over to our Flowise account. From the dashboard menu, let's choose Chat Flows to create a new AI agent workflow by clicking Add New. We will then be redirected to the Flowise Builder canvas. We will click on Save and rename our AI agent. Let's call this Data Analyst Agent and hit Save. From the canvas, we can click on the plus button at the top left. Here we can see all of the different node options that we can choose in building AI agent workflows and more. You see here we have agent nodes for building AI agentic workflows, various chain nodes, and chat models, which is very important to power your AI agent builds. As you can see, there's so many options available, from OpenAI, Anthropic, Hugging Face LLMs, Mistral AI, and GrokChat. We also have document loaders for building retrieval augmented generation AI agents, embeddings for handling data sources, LLMs from almost all of the available providers, agent memory, output parsers, prompt templates, retriever nodes for retrieving vector databases, and text splitters to handle vector data. We also have various different tools that will be available for our AI agents to access using tool calling functionalities and logics, and vector stores, which is a very powerful feature for handling data sources and knowledge bases for any types of AI builds. Flowise uses LangChain as its underlying architecture to create AI workflows. Flowise is essentially a low-code interface built on top of LangChain. The reason why you can see that all these nodes are under the LangChain architecture, which allows us to build AI workflows. To build our Data Analyst agent, let's click on the Nodes menu button. Head over to Agents and let's choose the Tool Agent node. Our Tool Agent nodes requires 3 subnodes. The Tool node, where we will hook up the different tools. We will give our agent access to execute various tasks as a Data Analytics AI. A Memory node to make sure our agent has context for previous conversation with the user. And a tool calling Chat Model. It's important to note that the tool agent will only accept an AI model capable of tool calling. In this case, we will hook up the Anthropic's Claude Sonnet 3.5 latest model. In the additional parameters field, here we can configure the system prompt we will give to our tool agent. This will be the system message that instructs our tool agent to carry out different tasks while conversating with the users. Now let's give our tool agent its brain. Let's connect the tool calling chat model by going to the Nodes menu into the Chat Models options. Let's choose the Anthropic Chat Model node. Let's then configure our API credentials. We can create our API credentials by clicking on Create New. Let's get our API key by going over to the Anthropic website. Click on the Claude menu and go to the API page, and you'll be redirected to the console.anthropic.com. Sign up for an account using your email. Click on Get API Keys from the dashboard menu. Let's create a new API key. Let's name this API key YouTube tutorial. Let's copy the key and paste this into the Flowise credential creation interface. Let's call our API credential YouTube demo. Now that we have our Anthropic API credentials, let's select our credentials and choose our AI model. For this build, we will choose the Claude Sonnet 3.5 latest model, and let's set the temperature to 0.1, which will ensure we're getting the most precise behavior from our AI model, minimizing too much creativity in its responses. Now we can connect our chat model to our tool agent node like so. Up next, we will need a memory for our tool agent node. Let's choose buffer memory as our memory node. Now let's add the first tool for our AI agent. From the Tools menu, let's choose Code Interpreter by E2B. E2B is an open source infrastructure that allows us to run AI-generated code in secure, isolated sandboxes in the cloud. Our AI agent is powered by Claude AI that is capable of generating Python codes in the background and uses the E2B code interpreter to run the codes and return data analytics and visuals using Python data science libraries. We can think of it as a small computer for the AI model. For our example, since we're building an AI data analysis chatbot, we would start the sandbox for every user session in our conversation with our AI data analyst agent. To create our E2B API credentials, let's head over to the E2B website and sign up for a free account. I've already created my account, so now we can go over the dashboard. Here we can get our API keys, which we will copy and paste to create our E2B credentials. Now we can connect our E2B code interpreter node to our tool agent node. So now we got our tool agent, its primary tool to execute data analytics and data visualization actions. Next, let's add a system prompt for our tool agent node. Here we gave it a prompt that says, "You are an expert data analyst assistant. Use the code interpreter tool to execute Python code that you wrote yourself to conduct data analysis and data visualizations and return your response to the user." Let us also add a capability for users to upload any files or document within the chat interface. In the top right corner, let's click on the Settings button, and in the File Upload option, let's activate the Enable File Uploads dial. And there you go. We're done building the basic functionality of our Data Analyst AI agent. We can now test our agent by saving our workflow and start chatting with our AI data analyst in the chat window. Let's now test our Data Analyst agent. Let's upload a CSV file containing financial data of stock market trends, and let's ask our agent to summarize the data for us. Here, you can see how our agent responded with the summary of the data contained within the CSV file we uploaded within the chat interface. It also gave us a nice data visualization from the data we provided. If we look at the execution that our AI agent did, we can see that it called the code interpreter tool correctly and used it to execute Python codes it generated in the background. Here we can see how our AI agent generated the visuals and analysis using Python codes expertly generated using libraries that are used in data analytics and data science like Pandas, NumPy, Matplotlib, and so on. Look how awesome the graphic gave us using the analysis from our data. This is just phase 1 of our build. In the next part, we will build additional capabilities and integrate automations to our Data Analyst AI agent to make it more powerful and capable of doing data analyst jobs for us. Let's push the test to another level to see what more our AI data analyst can do. Let's ask it to recommend other visualizations to further get insights of our stock market data. And there you go, in an instant, it gave us more visualization from our data. It also provided us with meaningful analysis and insights about the reasoning and details about the visuals it created for us. To wrap up what we have built so far, let's go ahead and look at our process map. Here, we have already built the basic functionality of our data analyst agent. We hooked up the code interpreter tool to our agent, giving it the capability to execute Python codes in the background, powered by Anthropic's Claude Sonnet 3.5 latest model, and making it do amazing data analysis and visualizations through conversating from the chat interface. We still have 2 more tools to build for our AI agent, and in our next phase, we are going to build the custom tool for our data analyst. This custom tool will give our agent the capability to scrape data from the Google Finance website to gather stock market data based on a search query or parameter we give it. The custom tool in Flowise will be used to trigger an n8n automation using JavaScript code to send a webhook response to our n8n workflow. The n8n automation workflow will then be triggered based on a query parameter set by the user through the chat conversation. The query parameter received by n8n through webhook will then be used to execute an HTTP request to access the API endpoint from Google Finance website using the SERP API credential we will be setting up. Then, once we executed the HTTP scraping action, we will store the data into an Airtable database, which we will set up later. This is the Google Finance website that we are going to scrape data from. Here, you can see we have the stock market data, which can consist of market index funds, top stocks performers and losers, cryptocurrencies, and so on. We will access this data by creating our own Google SERP API account to get access credentials and start scraping the Google Finance website using the n8n automation tool that we are going to build. Now let's start building our scraper automation tool. Let's head over to n8n.io and sign up for a free trial cloud account. Once we have our account, we will be directed to our n8n dashboard. Here, we can start building a new workflow for our scraper automation tool. Let's start by giving our workflow a name. Let's call it Google Finance Scraper. Now, in the center of our canvas, we can see a plus icon. This is where we choose our trigger node for our workflow. Let's choose a webhook trigger for our scraper automation. In this trigger node, we can see here the webhook URL, which we can set to various HTTP request method like post, get, and so on. We can also change the URL path. Let's call our path YouTube demo. Now, in order to connect our Flowise agent to our n8n scraper automation using this webhook trigger we created, let's head back to Flowise. In Flowise, let's go to Tools menu. Here we can create a new tool. Let's click Create and let's give our tool a name like n8n Respond Webhook. Then let's add a description for the tool. Note that this description is very important for the AI chat model to recognize what this tool is all about and enable it to call the tool properly. Let's also add an input schema to our tool. This input schema is what we will send to our webhook respond that will be sent to our n8n automation workflow. Let's name the property of our input schema as query of type string. Let's also add a description to describe what this input item is all about for our AI agent to learn when to send this data from our chat conversations. Make sure to click the required column here to check the tick box. Next, we need to write a JavaScript code that will handle the response to our webhook tool from n8n. If you don't know anything about JavaScript, do not worry since Flowise prepared a template for us by clicking the See Example button here. You can then edit this sample JavaScript code by changing the URL variable using the URL we get from the n8n webhook node. Let's also change the method to post, and let's add a body parameter using the query variable we set from our input schema. This process is explained from the Flowise documentation for your reference. Now that we created our custom tool in Flowise and we connected the webhook action to our n8n workflow, we can then go ahead and hook up the custom tool into our tool agent. Let's go back to the Flowise workflow canvas and let's look for the custom tool node within the tools option. Drag this tool into the canvas and let's set up the required fields. From the select tool drop down, we can now see the tool we just created earlier. Let's select the tool and let's attach the tool to our tool agent. Next, let's improve the system prompt we gave to our tool agent node. We need to add more instructions to our AI to enable it to use the additional tool like the custom tool we connected to it. This way, we can test if the custom webhook tool will properly respond and connect to our n8n workflow. Here, let's give it a more refined system prompt. Since this tool agent will be able to execute the scraping action using the n8n automation to the Google Finance website, we need to send the query parameter required by the SERP API endpoint to our n8n workflow using the webhook connection we set up earlier. Here, the query we need to send to n8n must be of the following items: index for searching market index funds, most active stocks, gainers, losers, crypto, and so on. Now, let's test the webhook from our n8n automation workflow to see if we can send the query parameter properly from our chat conversations. Let's head over to n8n, and in our webhook trigger node, let's click on Listen for Test Event, and then back to the Flowise agent build. Let's start a chat conversation with the agent. Let's chat with our agent and tell it to gather new financial data related to index funds. There you go. As you can see here, it called the tool properly in the background to execute the scraping task for new financial data related to index funds. Back to our n8n workflow, you can see here that the response we get from Flowise agent conversation returned the exact query via the webhook trigger, which is the query parameter here indicating index. Since it is now working, let's pin this data in our trigger node so that we can use this response over and over again while we finish building our n8n scraper workflow. Here in our n8n workflow, let's start to create the succeeding nodes to our scraper tool. Let's add an HTTP request node to connect with the Google Finance API endpoint using our SERP API credentials. To complete the required fields in our HTTP node, let's head over to Google's SERP API dashboard. From the menu, select the Google Finance Markets API. Here, we can use the provided curl code, which we can then import to our HTTP node in n8n. Let's copy the code, and in the n8n HTTP node, click on Import Curl. Now you can just paste the code to import and fill out the required fields from our HTTP node. In the API key, copy and paste your own SERP API key, which you can get from your SERP API dashboard when you signed up for an account. Now in the trend field under query parameters, instead of hard coding the query, which is index in this case, we can drag and drop the query value we get from the webhook trigger, which came from our Flowise agent conversation. This way, we can dynamically set the query parameter to whatever search term we are going to execute based on our conversation with the agent from Flowise. Let's test this step to see if our HTTP request node is going to get a response back from the Google Finance API endpoint to receive the data we want from our query parameters. There you go. It all came back with the data coming from the Google Finance API. Up next, let's add an edit fields node. This node will ensure that we're only going to grab the data we need from the entire data we received from our HTTP call. Here, we're only interested with the market trends data. Let's drag and drop this array of data to our edit fields node. Let's also grab the search parameters data so that we can grab the trend item, which will return the search query for this specific run. Up next, we will add another node. This one is called split node, which will make the array of data from our previous node split into items. Let's drag and drop the market trends array to split the data out. Let's also include the search parameter data so we can grab the query parameter into our database. Now to test the output, here we can see all of the data we want to grab and record into our database. Now let's also format the output from our split node to make sure we're getting the correct values from each of the items in our data. Let's add another edit fields node here. Now we can drag and drop each item into the field and edit the name or headers. We will test later if the number values we are getting will not throw any errors once we upsert them into our database. If we encounter error like getting a string output format instead of a number value, we will adjust our database column to format into string so we would avoid any error while upserting records. Now that we are getting the scraped data from Google Finance website, we need to create our own database. For this build, we will use the Airtable platform to create a database. Let's go ahead and create our new database using Airtable after signing up for a free account. Here we have our base table creation. To create the database we will use for our automation and AI agent build, we will use the import option to upload a CSV file that we created beforehand. This CSV file of stock market data contains the same columns and values based on the data we scraped from our n8n automation workflow using an HTTP request to access the Google Finance API endpoint. Let's go ahead and click on Add or Import button here at the top and choose the CSV file from the options. We will then use the CSV file saved from our desktop folder called Stock Market Trend CSV. Once uploaded, we will need to finish the setup to build our Airtable database using the CSV data by clicking Import. Now our database table is set, and all we need to do is edit the column formatting for each column values to make sure we're getting the correct data coming in from our n8n automation once we upsert the scraped data into our base. Let's also change the base name to Stock Market Data and the table name to Stock Data. Now our database is ready to use with the structure of each column setup. The next step is to connect this Airtable database we built into our n8n automation workflow. For this, we need our Airtable credentials by creating our personal access token to access this API endpoint. To create our personal access token, let's head over to the Builder Hub by clicking our account profile icon from the top left and access Builder Hub from the menu. We will then be redirected to the Builder Hub page where we can create our personal access token. To do this, let's click on the personal access token option under developers and click on the blue create new token button. Let's give it a name like stock market database. In the scope settings, we need to define permissions we give to our API access credentials. Let's choose everything except for the developer permission and the user metadata. Then we can identify what base we give all these access permissions to, in our case the stock market data we just created. Click on create token, and now we can copy our personal access token to be used in our automation credentials. Let's continue building our n8n scraper automation. Let's go back to n8n and add another node to our workflow. Let's look for Airtable and choose the create a record node. Here, we need to set up our Airtable credentials by clicking create new credentials. Then choose the default access token instead of the other one, which is OAuth 2. Let's now paste in the personal access token we copied from our Airtable Builder Hub earlier. Hit save, and now we can connect our Airtable database to our workflow. Let's then set up the required fields for this node. Leave the resource and operation field as default. In the base field, let's choose by ID settings, and now we need to copy the base ID of our Airtable database. We can get this ID by going over to our Airtable database page. In the URL, this part right here that starts with app is our base ID. Let's copy this and paste into n8n. Let's also copy the table ID to our node field where table ID is required from the Airtable database URL. This here where it starts with TBL is our table ID that we need to copy and paste into the node field. Now all the column headers from our Airtable database will be seen listed here inside our nodes since we selected the map. Each column manually option in the mapping column mode field. With this, we can drag and drop the values we are getting from the previous node where we get our pre-processed data from scraping using the HTTP request. It's very important to note that we need to test whether the formatting of the data we are upserting to our Airtable database are the same. Like for cases where the scraper outputs a string value instead of a number, this will throw an error when we try to create the record to our Airtable base. In cases where we can't change the output format from previous edit field nodes, like when we converted strings to number formats and it still outputs string instead of number, we need to adjust the field formatting in our Airtable database into a string to avoid getting error when running our automation in the production settings. One should take note of these types of error when maintaining this entire automation system. Let's now test this out and see if we can upsert the data we scraped into our Airtable database using our automation workflow. And there you have it. We've successfully recorded the finance data scraped from the Google Finance website using the Google SERP API access and HTTP requests we executed in our workflow. Now we are finished building our scraper tool that will run in the background automatically when our AI Data Analyst agent will be asked by the user to gather new financial data from the Google Finance website to be used for data analytics and visualization sessions at any given point of conversating with our agent. With this tool we gave to our Data Analyst agent, this data scraper tool we built in n8n will be automatically called whenever needed. Now we still have one more tool to build for our data analyst, and that is the retriever tool, which we will start creating next. This retriever tool will give our AI Data Analyst agent the capability of a retrieval augmented generation or RAG agent. The retriever tool will allow our agent to access a document store or a vector store that we will build to access all of the data that has been scraped using the scraper automation workflow we built earlier that records those data into an Airtable database. The goal is to make sure all the scraped data will be recorded automatically into a vector database, converting the data into vectorized information, which makes it more efficient for AI agent to access instead of a normal database like the Airtable we created. This will ensure a more robust data store system for any project we need to build using this same logic for any types of applications and enable our AI agent system to scale. Now on to the build process. First thing we need to do is create a document store within Flowise. Flowise's document stores offer a versatile approach to data management. This enables us to upload, split, and prepare our dataset and upsert it in a single location, in our case, in a Pinecone vector database. This centralized approach simplifies data handling and allows for efficient management of various data formats, making it easier to organize and give our AI agent access to our data within Flowise. To make this system more powerful, we will build an n8n automation on top of this data management system to simplify and run the data upsert or update automatically without having to handle this manually as it is currently designed within Flowise. In our Flowise dashboard, we can see on the right menu right below the options is the document stores. Let's click on it, and here we can start building our document store. Click on Add New button, and let's give our document store a name. You can see here we don't have data yet within our document store. Let's click on our document store created, and we will be redirected into the setup. Here we can add a new document loader. Document loaders allow you to load documents from different sources like PDF, TXT, CSV, Notion, Confluence, etc. In our case, we will use the Airtable document loader available here from the various options to choose from. Let's go ahead and choose Airtable, and now we will need to connect our Airtable credentials just like we did in our n8n automations. Let's create a new Airtable credential. Let's give it a name. Now let's paste the access token we got earlier. Also, as we did before, let's paste the base ID. Also paste the table ID. And for the view ID, let's copy that from the last part of the URL of our Airtable database. This one here that start with VIW. Let's paste that here. I will leave the rest as default, but I will change the limit to 500. This will mean that the limit it will return when we query our document store is within 500 chunks of data. Now let's try and click the Process Chunks button here at the top. Let's refresh this. And there you have it. We now upserted our data into our document store from the Airtable database. Here, we can see how our data were upserted into chunks within our document store. These are the same data we had from our Airtable database. Let's further enhance our document store now that we already have our document loader set up. In the above menu buttons, we can now see the option to configure our upsert process for this specific document store we created. Let's click on this Upsert Config button, and we will be redirected to the configuration settings. Here we have 3 different items to configure. We have the embeddings, which will handle the vectorization of our data. We also have the vector store, where we will store the vectorized data, and the record manager, which manages data entry and deletion of duplicate data that will be recorded within our vector database. This ensures we only get unique records every time we upsert into our document store. Let's click on the embedding setup, and let's choose the OpenAI embeddings. Here, we need to configure our OpenAI credentials. Let's create a new credentials by going to platform.openai.com/API keys website. We can create a new API key and copy and paste the key into our Flowise credential setup. In the model name, let's choose text embeddings 3 small. I'll leave everything here to default. Now let's go ahead and choose our vector store. From the choices, we will select Pinecone. Let's go ahead and create our Pinecone API credentials as well. Let's go over to pinecone.io and create our new account. I've already created mine, so once you're done with your account, you will see a dashboard like this where you can create your new index. This index will be our vector database within Pinecone. Let's create a new index and name this as Flowise Data Analytics. In the configuration, let's click on Set Up My Model button here, and we can choose the same embeddings model we selected earlier, such as OpenAI text embeddings 3 small. Let's leave the rest of this fields as default, but you're free to select whatever you want if you are on a paid version of Pinecone. Let's hit Create Index, and there you go. We now have our Pinecone index without a record in it yet. Now to get our API key from Pinecone, we can go to API keys from the left menu and let's create a new API key. I already have mine here, so I can copy this key and paste this into the Flowise credential. Now let's choose our credential, and in the Pinecone index field, let's choose the index that we just created. Let's also create a namespace within our index. This will make sure we are categorizing the data coming into our index from the Pinecone database. I'll call mine finance data. For the rest, I will leave it on default values. Then the last item, we need our record manager setup. Here let's choose Postgres Record Manager. Now we need an API credential for Postgres account. To get this, we need to use Supabase to create a Postgres database. Let's sign up for a Supabase account. Once signed up, we can create a new project, and let's name this project Flowise Data Analytics AI and set up the database password. Remember this password, as this will be needed later in the setup. This will take a few minutes to set up our project and start using the credentials. Now that our Supabase project is ready, let's head over to Project Settings. Under Configurations, let's click Database, and we will be directed towards the database connection parameters, as you can see here. These are all the credentials we need to set up the record manager from Flowise's Upsert configuration. So back in Flowise, let's name our Postgres API with something meaningful like Postgres Supabase API. Let's copy and paste the username and the password we created earlier. Now for the host name, let's also copy the one from Supabase, the database name as well. For the port, we'll also copy and paste it here. And the last part is to set the cleanup method. We will choose full to make sure no duplicates will be upserted into our database. Let's save this config. Now we can click on Upsert button here, and this will now upsert our document store data into our vector database, fully managed by our Postgres Supabase setup. There you go. We now upserted 6 records into our vector database, and you can see how it has been chunked into 6 items. Back in Pinecone, we can now see that within our index, there is actually 6 new records created. Our document store is now complete. Now that we have our document store set up, what we're going to do next is to automate this step here within our document store. This part here under options, where we can click on preview and process option. This is what we're going to automate in the background using n8n. The idea here is that in Flowise, you need to manually go over here into your document store and click this preview and process button to ensure your data will be updated into the vector database every time new set of data is coming in from the Airtable database. This manual process can actually be automated using n8n automation solution, employing an API endpoint access. In a nutshell, once the user scraped for new data from the Google Finance website, it will then be recorded in the Airtable database. To make sure we can capture this new stream of data into our document store without having to manually update the database, we will use n8n to do this for us in the background. So let's head over to our n8n account. Let's create a new workflow and name this with Flowise Doc Store Upsert Automation. Let's now add a trigger node. We will choose Airtable, and under triggers, we will select on new Airtable events trigger. This will make sure that whenever new action has been made, like upserting of new data into our Airtable base, this n8n workflow will run automatically to process the upsert of this new data into our vector database. Let's set the trigger node and use our Airtable credential. Under poll time, we will choose every minute to make our workflow check for new changes that happened within our Airtable database. Let's also copy and paste the base ID and the table ID to connect our workflows. Under trigger field, this requires a timestamp, which in our case, the extracted date column will be used. Let's then test this trigger and click on Fetch Events. Here you can see we're getting the data coming in from our Airtable database. Let's then add another node. We will choose the Edit Fields node and name this as Document Store Variables. This node will store the document store ID and the base URL of our Flowise account. We need this data to call an API action so that we can automate the upserting of new data within our Flowise document store using this n8n automation we will be creating. This workflow is inspired by the YouTuber Mr. Leon Van Zyl, and you can watch a detailed tutorial on how to set up automations for document stores and other Flowise contents in his channel as well. Let's add each of the variables we need. The document store ID, which we can get by going to our Flowise document store we created. And in the URL here in the last part is our document store ID. Let's also set the Flowise base URL. Let's copy and paste the base URL here from the Flowise page. This might be different for you if you are using a cloud account or if you're deploying your Flowise instance on your local machine. In my case, this instance is deployed using Render. Next, let's add the HTTP request node. This node will execute an HTTP action to trigger the upserting of our document store whenever new stream of data comes in from Airtable. We can see how this API can be implemented by going through the API documentation from Flowise. Here you can see we have the getSpecificDocumentStore action with all of the steps and parameters to use in order to execute the getRequest action. We need this getSpecificDocumentStore action to identify which document store are we going to select and trigger processing for Upsert action within Flowise. Now in our HTTP node, let's drag and drop the URL values from our previously set up edit fields node. We now need to use the API endpoint stated within the Flowise documentation by adding /API/v1/document-store/store/. Then we can drag and drop the document store ID we get from the previous edit fields node as well. This is how we retrieve a specific document store within Flowise using an HTTP API access request. Now if we test this out, we will get an authorization error. This is because we still need to get an authorization credential from the Flowise API endpoint by getting an API key from our account or instance. Let's set up our Flowise API credentials. Under authentication, let's choose generic credential type, and under generic auth type field, we will select header auth. Here, we can set up our header authentication using our Flowise API key. Let's rename this credential to header auth Flowise API. Under name field, make sure to indicate authorization in this very same type case, since this is the required name for this to work. Now, to get our API key, let's head over to our Flowise dashboard, and under API keys, let's create our new key and name it Data Analytics Chatflow Key. Let's copy the key and paste into the credential from n8n. Now, if we test this HTTP request node again, you can see that it's working, and we now retrieve the data from our document store. After getting the data of our document store from Flowise using the HTTP request node, let's add another edit fields node. Let's name this extract document loaders. This node will extract all the available document loader present in our document store, which we retrieved from our previous HTTP node. Let's drag and drop the loaders array into our set field node. Now, if we test this out, we can see that an array of data containing details of all the document loaders available from our document store will output in this node. In our case, we only have one document loader, which is the Airtable loader we just set up. Let's also add a filter node. We need to set up a filter so that whenever you have multiple document loaders from your Flowise document store, we can only filter the specific document loader we are interested in upserting. In our case, we only need the Airtable loader. And so we want to filter all loader ID that is not equal to PDF loader. This way, we can keep the output from our Airtable loader and proceed to the next node just as we have in the output when we test this out. Next, let's add a loop node, and let's also add another HTTP request node after the loop. Let's rename this HTTP node as process chunks. For the URL value, just like what we did in the previous HTTP node, we refer back to the API documentation from Flowise. The API call we are interested in is the process loading and chunking operation for our document loader action. Here in the node, let's change the method to post. In the URL, let's convert this to expression. And then let's copy the base URL value the same way we did in the previous HTTP node. We need to add the following command after the base URL /API/v1/document dash store slash loader slash process. And that's it. We then also set up the credentials for authentication. Then let's turn on the send body dial here. In the body parameters, let's add the store ID and drag and drop the value we got from previous nodes. Let's also add loader ID and use the value from previous nodes as well. In the done path of our loop node, when we're done looping through each of the document loaders we have from our Flowise document store, we will then go to the done path. Let's add another node here. This node is another HTTP request node. This node will call the API action to upsert the chunks from our document store into our vector database. From the Flowise documentation, we can see here how it's implemented. In the HTTP node, let's change the method to post. For the URL, let's set up the URL value by, again, dropping the value of our Flowise base URL. Then we add the new command /API/v1/document-store/vector-store/insert. Then, for the authentications, let's set up the credentials again. Let's also activate the send body ticker. And in the body parameters, let's add the store ID and drop the store ID value from the previous node. Now, we are done with the workflow. Time to test if everything is working. Let's also add a wait node to make sure we're not going to overload the request when looping through each of the document loader in Flowise. We can put a 2-minute wait time for each loop here. Now that we've built all of the n8n automations needed to ensure automatic executions of the tools we've given our AI agent and the document store, which will give it the capability to update knowledge database efficiently, we also need to create the retriever tool that we will connect to our agent. Let's head over to our tool agent chat flow. Now let's get the retriever tool within the tools node options. Let's drag and drop this tool to our canvas. Here, we can see this node requires a base retriever. We also need to give it a name and a description. This description is important that we clearly define it so that our AI agent will be able to identify when should this retriever tool be used or triggered next. Let's add the retriever node to attach with our retriever tool. Let's go ahead and go to the vector store nodes. We will select the document store vector node here. Let's drag and drop it into our canvas. Let's use the retriever option from this drop down here and connect this node onto the retriever tool. Let's also select the document store we created earlier. In this case, we named it Flowise Tutorial. In the retriever tool, let's name this retriever as Finance Data Retriever. And in the description, let us give it a clear description like this. Let's hit save, and now we connect this retriever tool to our main tool agent node. Save this workflow. And here's the complete build for our Data Analyst AI agent. Now for the final tests, let's now chat with our Data Analyst agent. Let's say hello first to see how we can proceed with the interactions. Here, our AI agent gave us details about what it can do for us and various different options to request for our AI Data Analyst agent to execute. Let's try and test the capability of our agent to scrape for new data using the tool we gave it, which we built from n8n. Nice, it accurately asked us a query parameter that will be used for executing the scraper tool to get data from Google Finance. And there you have it, a nice visualization it gave us after getting the data we asked for. For context, in actual, this process took a few minutes before our AI agent can give us the correct feedback about the actual data we needed based from the latest scraping activity we just requested from our agent. This is because executing this request uses asynchronous runtime in the background. And we also implemented waiting periods for our automations in n8n. In reality, these runs you see are not instantaneous and will use a lot of tokens to execute, so be mindful of your LLM cost. Let's push this further. Let's ask our data analyst agent to give us a different visualization for the cryptocurrencies data we just scraped. There, look at how beautiful these visuals are. This may be just a basic data analytics and visualization, but imagine you have this capability at your fingertips. This process will take a lot of effort if you do this manually using Python for data analytics. The power of Claude Sonnet AI's coding capability made this possible, and with the E2B sandbox code interpreter, it's a perfect combination. Additionally, the n8n automations we built running in the background makes this system more efficient in handling real-time data queries and data processing for seamless analysis and visualizations on the fly. Now, to make this even more exciting, let's try and give our data analyst data that is not available from its knowledge base, which is the document store we connected with it. Let's use the file upload capability within the chat interface for our conversation. Here, we're uploading a CSV document containing ETFs, or exchange traded funds data. Let's see how our data analysts figure out what data to use when interacting with us. I'm using the test chat interface within the workflow canvas to see how our agent operates in the background. There you have it. It gave us the summary of the CSV file we uploaded, and it correctly summarized the ETF data we gave it. Here, we see the tool calling function it executed in the background. It used the code interpreter tool to analyze the new data we gave it and run the Python code it generated to give us the data visualization. Not only that, it also analyzed the data and gave us a comprehensive explanation for the visuals in our ETF data. To all of you who made it this far into this full step-by-step tutorial on how we built this awesome data analytics AI agent using Flowise and n8n, thank you from the bottom of my heart for supporting my channel and taking your time to learn awesome AI applications like this. If you want to replicate this process or want to follow along with this tutorial, give it a go and download the free resources I provided for you from the link in the description. As always, these resources are for free. Some of them are also inspired by other creators who gave same resources for free. So all I'm asking is to give some love and support this channel by clicking the like and subscribe buttons. Hope you get something out of this tutorial. I would love to hear from you. Comment down below and give your thoughts about this video. Until next time, see you on the next video.